This is the first videos for chapter 5.3. So this one we will talk about the present value of an annuity and the amortizations. So we have two things about annuity we want to talk about. The last sections we talk about the ordinary annuity. For this one you put in regular periodic payments, it can be payments or you can call this deposit, and you try to save up a big amount of money. So for future, and you earn interest along the way. Usually you save this for retirement or buying the down payment for a house, etc. For retirement, down payments, etc. So that's the ordinary annuity. And the payout annuity is like you already have a bunch of money, you already retired, you want to draw some money out every month or every year, like that. So the second one is the payout annuity. So you already have a big amount of money in the account, and then you are going to withdraw regular periodic payments, and the money will earn interest in the account until the balance go to zero. So money earned interest in the account until the balance goes to zero. So because you have remaining balance after each withdrawal or the payments, so the remaining balance will continue to earn interest until the account go to zero. So they say if you save your retirement with an IRA or an annuity or both, you will do a lot better if you start really early. So when you're young, you get a job, you want to put away a little bit money slowly until you're retired. This allows you to take advantage of the magic effect of compound interest over a long period of time. If you remember the last section, the bank loan you money, so they want to earn the interest, so you can do the opposite. You put in money in an account that accumulate interest, so by the time you retire, you will have a bigger amount of money to work with. In an annuity, you started with nothing, put money into an account on a regular basis, and end up with money in your account at the end. So this is the ordinary annuity, right? So this type is going to be the ordinary annuity. Is the first type. For payout annuity, so this is different type. you start with the money in the account and you pull money out in the account on a regular basis, and the remaining money in the account earn interest. After a fixed amount of time, the account will end up empty. So that's the payout annuity. So the first type, we can define an annuity as a sequence of equal regular payments into an account in which each payment receives compound interest. A saver who utilizes this annuity can accumulate a sizable sum. So I'm going to say this is about ordinary annuity, annuity, and this information is also about the ordinary, right? An annuity can be payout instrument, so the second one would be the payout annuity. So this is about a payout annuity, and this is about a payout annuity. Can be payout instruments rather than saving instruments. After you retire, you might wish to have part of your savings sent to you each month for the living expenses. You might wish to receive equal regular payments from an account where each payment has earned compound interest. Such an annuity is called a payout annuity. So still talking about payout annuity. Payout annuity are also used to pay for a child's college education. So some grandparents or parents can save up money, and then when the child get to the college age, they can withdraw money each month slowly. That's a payout annuity. So we have some formula here. So this one is you need to find the present values of the payout annuity, and you know the payment. So this would be the formula I will use. I try to keep those letters very consistent with R and N and T. Some book may simplify it like that. So I is your R over N. I is R over N because it's the interest in each compounding periods, and the capital letter N is NT, mean how many times you're going to compound. So your book actually have some weird letters, so I just put all of them here, so in case you are confused, you can figure it out later on what they are talking about. The second part is for sinking funds, meaning if you know the future value and you want to figure out the payments, so you can do it like that. So I'm going to leave this here first. If I found a book formula for the second one, I will let you know. Somehow I didn't print out here. Alright, so let's see. Let's look at the first example. The first example here, we are looking for the present values of an annuity. So let's see. This say Tim and Carol. We have two people. They graduated from certain school, and they agree they are going to put down an endowment to fund the school. Tim say that he will give $500 at the end of each year. $500 at the end of each year for 9 years. So this $500 is a periodic payment. So again, you don't have a lump sum of money, so periodic payments here, that's why it's related to the annuity. And Carol prefer to give just a big amount. What is that big amount? Can she give equally to the present values of Tim's annual gift? So we're trying to look for the present value. If the endowment is funded, can be earned 7.5% compounded annually. So let's write down what we know. So this is chapter 5.3, and then we know payment, right? And we need to find present values. So I'm going to write down the formula, the one that we looked at earlier, that allow you to find present value is this one, right? So I know payment, I can plug in payment. I need to find the present value. So I'm going to write down the formula. So present value equal to payment 1 minus 1 plus R over N negative NT. So be very careful. Make sure you use the negative sign here. This is the common mistake a lot of students have over R over N. Okay, so we don't know present value, but we should know payment, the interest rate, how many times compounded per years, and how many years, right? So if you want to, you can pause the video and write down those information first and plug it to the formula, and then we can check, right? So hopefully you get it right. Payment is $500 at the end of each year. So the R is 7.5%, which you change it to 0.075, right? And then N is compounded annually, meaning once a year, right? And T is 9 years. So those are my information. I'm going to plug it into my present value formula. My payment is $500. 1 minus 1 plus 0.075 divided by 1 raised to negative 1 times a year for 9 years. And then 0.075 divided by 1, right? So the annually once a year make this a little bit cleaner. If you're very good at, you can plug it in one time. I won't, because I'm not that good with calculator. So this is 0.075 divided by 1 is just 0.075 plus 1 is 1.075, right? Raised to negative 1 times 9 is negative 9 divided by 0.075, right? Okay, so I'm going to use my calculator and don't round this number until last step. Alright, so let's see. Let's get my calculator. I'm going to do this part first. So it's going to be 1.075 raised to, raised to. Don't forget I should use the negative sign, okay? Negative 9. Enter. So this is the answer here. I'm going to use 1 subtracting and second negative, so get the answer there, right? So you can pick up the answer using the second and this button, negative, because the answer is here, right? Some of your scientific calculator may be slightly different. Just find the answer button and pick up the answer you just have. So 1 subtract that is this, and then I need to divide by 0.075, right? So I should have my $500 times 6.378 something, right? Don't lose that decimal number. Just keep it in the calculator, and then I need to multiply that by 500, right? So together I should have $3,189.44. So we have 2 people want to contribute to the school. One person is going to put $500 into the account every year for 9 years using those interest rates. The other person just want to give it one time. So the lump sum, the present value, represent the money the other guy is going to contribute to this account is going to be that. So that would be my present value of, what does this say? Let me find a funny question. So that is the lump sum Carol should contribute to the account that will equal the present value of Tim's annual gift. So hope that makes sense. Like we know the payments, we plug into the formula to find the present value. So that's number one. And then we're going to look at number two. So if you need to pause the video and write down some information, feel free to do it. Okay, number two is about car payment. So we have a car cost $19,000 after a down payment of $2,000. So normally the dealer wants you to put down some money before you take the car. The balance will be paid off in 36 equal months. 36 months is how many years? So 36 divided by 12 means this loan is for 3 years, right? The interest rate is 6%, which is kind of reasonable on the unpaid balance because it's a smaller loan. Found the amount of each payment and how much interest will be paid. So the car costs that much, right? But they put down a down payment. So my loan amount is not going to be 19,000, right? What is my loan amount? So let's write that down. Number two, the car costs $19,000 and then your down payment is $2,000. So the loan amount should be 19,000 subtracting 2,000 equal to $17,000, right? So you're only borrowing $17,000. So this could be one of the common mistakes. People forgot to subtract the down payment and they calculate everything from 19,000. So you're not actually borrowing 19,000. You're only borrowing 17,000. Okay, so this one is the, like sometimes you don't have a hard time to decide this is future value or present value. So this is present value because you're buying the car today, right? You're not buying the car in 5 years, right? So this is the present value of the car loan. Okay, you want to pay it up in 36 payments, so you can use it to represent the big N, which equal to NT, or you can say this is going to be 3 years and 12 times a year, right? Either way, the interest rate is 6%, and that's it. How much interest they will pay, we can find that later. So they want to find the amount of payment. So we need to find payment given the present value, right? This is the present value of the loan. So we look at those formula that we have. Which one is for payment? So this is for payment with the present values. Let's see. I think it's on the other handout. Oh, sorry. Somehow I put the formula here. So let's look at this. So I know the present values, so the payment, so this is a amortization like formula. So we're going to move that formula a little bit higher for this question. So we didn't talk about this. So amortization is going to be a loan if both principal and interest are paid by a sequence of equal periodic payments. So a lot of time, like a car loan and a house loans will use this kind of amortizations. So when I need to find payments and I know the present value, I can use this formula, right? So I'm going to write down the formula for you. Let's see. So payment equal to present value R over N 1 minus 1 plus R over N negative NT. Okay, so let's write down what we know. So we don't know payment. but we know the present value of the loan is $17,000. The R for this, R is 6%, which is 0.06. And then N, because it's monthly payment, so it's going to be 12 because it's monthly, 12 times the years. And then they say T is going to be 3 years, so we can think about it as like N equal to N times T equal to 36 payments. So we can put it down, plug it in. We have the present value for the loan is $17,000, times R is 0.06 over the N is 12 over 1 minus 1 plus 0.06 divided by 12. Negative N times T is 36, right? So I'm going to just write one time. N is 12 times some years times 3 years, right? If you want to put down negative 36, that would be fine. So 17,000 0.06 divided by 12 is 0.05. So we have 1 minus 1.05 raised to negative 36, right? Okay, so like the way I do it is probably not the way you do it, but I usually do the bottom part first. 1.05 raised to, make sure you use the negative sign, 36, hit enter, and I use 1, subtract my previous answer, and then I use 0.05 divided by, again, second my negative sign, the answer. So that's what I'm multiplying by, look like. Is it right? We're a little bit off, so let me double check my stuff. So let me see, 0.06 divided by 12 is 0.005. Sorry. And that's one of the very common mistakes, like people write down with 1 0 less or something, because like the number look like off to me. So I'm just like trying it one more time. So okay, let's start from the beginning. So this is 1.005 raised to negative 36, and then use 1 minus, pick up the answer, use 0.005 divided by the last answer. Okay, that looks right. So it's very, very easy to make a mistake, so make sure you try very carefully, because if it's a $17,000 loan for 6 years for car payment, probably it's a few $100s. So if it's like few thousand or $30, so you would know something's not quite right. 0.030 something, right? Keep that number in your calculator, times 17,000. Oops, too many zero. Okay, so my car payment should be $517.17. So that seems to be reasonable for car payment. So, but extremely careful with the decimal point, because sometimes I will lost a zero there and then my number is totally off. So that would be my car payment each month. Okay, the question also asks you to find the total interest. So the interest you pay is going to be totally how much payments you put in, subtracting the loan amount, right? So the loan was 17,000. Don't forget you only borrow 17,000, and the total payment would be each month you pay $517.17, and you pay how many months? 36 months, right? So you pay 12 times a year, 3 years, right? Totally 36 months. So 517.17. If it's money, most of the time they round it to 2 decimal places. Multiply 36 would be 1861812. So this is totally how much you pay them for the car over the loan. time. And then subtracting my loan, which is $17,000, the interest you pay was $1,618.12. So that's why they want to loan you money, so they can make money on the interest, total interest. Okay, so that would be for the first video for chapter 5.3. So some of this information are pretty useful, and you can calculate your car payments and stuff like on your own. Thank you.